are going to focus on 1.4 notes, which is how can you determine if a linear relationship is increasing or how is it decreasing? So we're talking about a walkathon today. Walkathon money is going to be used for books at the children's ward of the hospital. Money is placed in an account and withdrawn weekly. Each week, money is taken out of that account. So using this table on the left that they gave us, we have to answer some of these questions. What do you think the graph of this data would look like? What do we think the graph? So we want to describe the type of line that we're going to see. So let's look at our patterns here first. Let's look at the left side where it says weeks. What is this increasing by? What's the number increasing by in weeks? No, the other one. Okay. So now, Robert, what's this one doing? Decreasing? Is it? It's by 12? 12. Yep, 12. Perfect. Thank you. So we have a pattern going here. So when we see patterns like this is sort of stuff for your quiz on Wednesday. Determining equations and how to write them based on what a table looks like. So based on the patterns in that table, what should we expect the line of a graph to look like, Stephanie? I'm sorry? Yep, I just didn't hear you. You could say straight. Yeah, a straight line. Yeah. We should expect this to look like a straight line. Why did you think that, Stephanie? Because they're all even numbers? Or what's going on with these? Is this pattern ever changing on the right-hand side? It's the same number. Do you have something to add to it? So it's the same thing, what does that really mean then when it's the same thing? It's our constant. So that's like our slope or our constant in our equation. So this would be a linear line, a straight line on a graph. It says, does this table represent a linear relationship? And how did you decide that? Aiden, is this a linear relationship? Yeah? Why do you think that? Mason and I were kind of just talking about that. I agree with you. Because the same amount, what's that same amount really called again? Yeah, because there is I'm going to do CROC, constant rate of change. And we see that over here where we have our negative 12s, and they're all going up by 1s over here. So we have a constant rate of change. Part A, it says, how much money is in the account at the start of the project? When they start this project and they haven't done a thing yet, Mason, how much is in there? Thank you. $144, because this is the amount at 0 weeks. Perfect. Does everyone see that? Before they even start, at week 0, which means they haven't started yet, how much money are they at? Well, let's look over there. And Mason saw that was $144. How much money is withdrawn from the account each week? We're looking at the table, Ava Messing. 12 what? $12. So each week, there's $12 taken out of the account. And we can see that because, like Stephanie and Mason were saying, that's our constant rate of change. From week 0 to week 1, $12 is out. From week 1 to week 2, $12 is out. You see how we can piece all this stuff together just by looking at the table? Our next step could even be writing the equation if we need to. For 3, it says suppose the students continue withdrawing the same amount of money each week. So we know that Ava just told us they're taking out $12. So suppose they're taking that out each week. Sketch a graph of this relationship. Make sure you label the info on each axis. Okay, so first we got to create our axis. We're going to have 0 down here. Let's make our y-axis amount of money. amount of money. And let's go by 20. So we have 20, 40, 60, 80, 100, 120, 40, 160. Yeah, by tens. Each line is 10. So every other line would be 20 then. And then our bottom is going to be the amount of weeks. So each line is, we're just going to go one. So I'm going to skip a line. So I'll be 2, 4, 6, 8, 10, 12, 14, 16, 18. There's 18 weeks there. So I created the graph. Now I have to plot my points. Well, I can plot some of them because weeks 0 through 5, they already told us. After week 5, I'm going to have to do some calculating. I'll give you guys a minute, about a minute to get this part of your graph set up. Okay, everyone should have their table labeled like I did in the red. We're going to go on to plot it now. So first, we're going to take all the points that were in our table from up above, the ones that they stated to us. At week 0, Lily, what did they say? How much money do we have? Perfect. So I'm going to go right up there, 144. And then Gavin, at week 1, what do I have? 132. And then Gracie, week 2. Okay. Anthony Marisi, week 3. 108. Brayden, week 4. 96. It should be a little bit up. And then week 5, Eliana. 84. Okay, so that's what they told us. But they said, suppose the students continue withdrawing the same amount of money each week. Well, we know that they are withdrawing how much each week, Elena? Sorry? 12. So based on this, we can keep going. So at week, what are we at? Week 6? At week 6, week 5, we were at $84. So what would we be at week 6, Sal? What would we be at week 6? If at week 5 we're at $84, and like Elena said, we're withdrawing $12 each week.
It would be 72.
Yeah, perfect. Week 6, we're at 72. Okay, so if we keep going with that kind of pattern, let's see. Becky, what would we be at week 7? 60. Maria, what would we be at week 8? sorry? 48, yep. 48. Week 9, Ashley? 36. Zane? 24 for week 10. We're almost there. We want to go all the way to 0. Gavin? Next week? At week 11? Oh, you're writing it down? We had 24 in the previous week. So what would we have in this week then? 12. All right, I think we're going to have one more. What about our last week, Brayden?
0.
Yep, at week 12, we have $0. So what do we see going on with this line? Joey? It's going down at a constant rate. So for us to state in our first question, where it says, what do you think this graph, the graph of this data would look like? We were correct by saying it's going to go down. So here is, let me see if I can make this line a little bit more accurate. My points are not exactly on. Okay, so this is what our graph looks like. we were able to plot the entire thing because we were able to find the constant rate. Because we knew that, we can find the rest of the points and determine all of it. So now we can figure out our line. So if we go on to question 4 on the second page, it says write an equation that represents the relationship. Explain what information each number and variable represents. Is anyone still creating their graph, or can I go on to the next page? Hand on your head if you're done creating your graph. Okay, perfect. Next page. So I want to write, since this is a straight line, Anthony Marisi, what kind of equation am I going to use? What's the basic equation that we use for like a straight line, a linear line? Y equals mx plus b. Perfect. We know we're going to use that equation because of the line that we were given. Now I can, Peyton, help me piece together what this is going to look like. So what would I put in for my m? What's m mean? I have a y. I'm creating an equation. What's the m represent? Do you remember what that really represents? Yes, it technically is going to represent money in this case. But what's m? I'll let you know that it. What if I told you that the m means your slope? Are you able to tell me what my slope is then? Our slope is our constant rate of change that we determined looking at that graph and looking at that table. What was my constant? Right, what was the actual number of our constant? It was negative 12. So that's why it's going down. Each week it's going down $12. That would be our slope. So if I were to go back to this first page. Did I not go back? Oh, I see. Okay, there it is. So if we were to go back to this page, Peyton, I could see that my slope, it's going down. It's going down by 12. Going down by 12. Do you see my slope there? That's our constant. So when we go on to this next page, my slope, you just said, would be negative 12x plus. Now what would my b be? What's the b represent, Aliana? What's the b represent? 12? Not exactly. What does the b represent usually in an equation like this? What does that usually show? Blake, do you want to help her? You're not sure? Lily, do you want to help out? What's b represent?
What if you like the weeks going like that?
The weeks? Not exactly. Eliana, do you want to try again? It'd be 144, which is our y-intercept. When we're at 0 weeks, where is it crossing the y-intercept? Now, Eliana just told me it's at $144. So if I were to go back again to this table, here it is right here, 144. That's where it's crossing our y-intercept, which is what our b is always representing. Sometimes it never crosses the y-axis, so sometimes we don't ever have a b. In this case, we do, because that's where it crossed our y-intercept. It doesn't always start in the y-intercept, though. Sometimes it just crosses through it, and where it crosses through the y-intercept, that would be your b. Okay, so now let's piece together what everything means. What is our, I'll give you the y equals the number at the end of the given week. What does my, Robert, negative 12 represent? What does that represent? Yeah, it shows, negative 12 shows it decreasing. Shows that it decreases $12, whoops, $12 every week, right? Okay, let's piece together the rest. Let's go on to our x. X means, let me put these in red so you can see them better. X means the number of weeks that we are looking at. We don't always know how many weeks we're talking about. And then lastly, the 144. I will look later today and let you know. Gracie, what does the 144 represent? Where it started. The 144 shows us where it started. So our negative 12 shows it decreasing $12 every week. Our Y is the money at the end of the given week. Our X is the number of weeks, and the 144 is where it started. So for question 5, it says, is the relationship between the number of weeks and the number of money left in the account linear? So we're looking at number of weeks to the amount of money. Angela, is it linear? Yes. Why do you think that? Because why? Perfect. Because she saw that because it has a, I'm going to put CROC for constant rate of change. And there's also another way now. We know, Lily. Yep. We know that it's because it's straight line. There's one last thing that we know that this is linear. Based on what we just did. Can someone else, Philip, can you tell me, based on the tables, based on the graph, based on, in question 4, our equation, how can you tell me that this is a straight line or a linear line? Yes, it does. What did I tell you about linear line equations? What kind of equation do we always use when there are linear lines? What types of equations? We looked at this in question 4. Y equals?
Y equals mx plus b.
Yeah. So we know that this is a straight line. Thank you, Philip. We know this line, this account is linear because first, it's a constant rate of change. Second, when we looked at the graph, it was a straight line. And third, when we looked at the equation, it was in the form y equals mx plus b, which all shows us that this will be a linear line. Now in part B, it says, Mr. Mammer's class also raised money for the walkathon. They used the money to buy games and puzzles for the children's ward. Keenan uses a graph to keep track of the amount of money in the account at the end of each week. So he created this graph. They raised money, and he created this graph. Let's look at it. It says on the left-hand side, it's the amount of money. And on the bottom in our x-axis, it shows the amount of weeks that it was done in. So this is the amount of money in our weeks. In question 1, it says, what information does the graph tell us about the money in Mr. Mammer's class account? What can this graph tell us about the money in the account? With your shoulder partners, or if you're a table of 3, you can work as a table of 3. Talk for about 2 minutes as to what the information in the graph tells you about their money. I'll give you about 2 minutes. So we are piecing together what this graph is looking like. So Mason, did you want to start us off by explaining a part of it? Okay. I'll call on someone else. So let's start with that. The money went down $10 every week. That's a great start, Mason. Okay. What about Isabel? What else do you see?
It's a constant rate. It's a straight line.
Yeah. It's a constant rate, which is what he was just saying. It's a constant rate of $10. Where are we starting at? What's the class starting at? Class started. Whoops, let me erase that. Class started with $100. There's one last thing that I think we should talk about. Oh, Mason. It definitely can, because this is a straight line. We can use the form y equals mx plus b because you already told us what our slope is. So from there, we would just have to figure out our y-intercept and put it in that equation. That is very true. Rebecca, do you see anything else that we can add to this? It's a linear line, that's right. What about after 10 weeks? What happens to the amount of money? Let's have Rebecca answer it. It's okay. After 10 weeks, Rebecca, how much money will they have? They have $0. So those three things, Elena. I'm sorry? Oh, you want to help us with, okay, we'll get there in a minute. Okay, so we can see from this graph that it's in the y equals mx plus b form, or we can put it in that form. The money goes down by 10, which Mason and Isabel told us is our constant rate of change. They started with $100, and that after 10 weeks, they don't have any more money. It's at $0, and it will stay at $0 until they put more money in the account. So, Elena, do you want to help us create this table? It says make a table of data for the first 10 weeks. Well, I don't know what happened to our table.
How many do I say?
Why don't you tell us 0 and 1?
Okay.
0 weeks. Let me fix our graph a little bit. Okay, at 0 weeks, what is it at?
100.
100. And then what about week 1?
$90.
$90. Okay. And Samantha, can you tell me 2, 3, and 4? At week 2, how much money am I at? 80. Week 3? 70. Week 4? 60. Do we see a pattern going here? Ava Demers. Week 5, 6, and 7. Okay. Okay. Perfect. And then Aiden? 8, 9, and 10? $20? $10? $0. So based on that graph that we just had, we were able to create our table. This table looks a little different than that one on the front page, doesn't it? But it's still giving us the same type of information that we want. It's just written differently. Blake, do you have a question? Oh, I did forget our dollar signs. Thank you. Here, I'll squeeze them in right here. It's okay. We still have to add it in. Okay, for 3, it says explain why this table represents a linear line. Why does it represent a linear line, Lily?
Because it's going down at a constant rate of $10.
It has a constant CROC, a constant rate of change. A constant rate of change of, I'm going to say negative 10, Lily, because yes, it's going down by $10, but if I just say of 10, that shows that it's decreasing because I have that negative there. As the weeks, it's going down by $10 as the weeks increased by 1. So, as our money goes down $10, the weeks are increasing by 1. Mason, do you have a question? Yeah, you can help us with that in a minute. Okay. Can I flip to the next page? Does everyone have this information down? Yes? Okay. Okay, I'll go back. I'll leave it right here. I'll give you about a minute to finish writing this in. Okay. So let's go on to question 4, our last page. Mason, you said you wanted to start us off with this question. It says, write the equation that models a linear relationship. Explain what information each number and variable represents. So what kind of equation are we doing again for this, based on the graph we were given? Okay, I'm going to write that up here so we can look at it. Y equals mx plus b. Mason. In Mason only. We have my y. I'll put that in for you. What would my m be? Negative 10. And why is that? It's my slope. It's my constant rate of change. And I'm going to put my x here. Plus, what is my b, Mason? Plus 100. Because that's where it crosses the y-intercept. When we're at 0 weeks, that's my y-intercept. Perfect. Thank you, Mason. Now I need help breaking this down. Like I said earlier, this is kind of like that quiz, Investigation 1 quiz that we're going to do. So, Brayden, I'll give you your y. But can you help me with the m? Y is the number at the end of the given week. Of the given week. So like the amount of money given at the given week, at the end of the given week. Okay? So, who did I say? Brayden. My M? What would my M be?
The money that it goes down by.
Okay, so my M is negative 10, right? And that is the money it goes down by each week. Perfect, which is also like saying our constant rate of change. My X is the number of weeks. And lastly, Sophia, what is my 100? I'm sorry, what did you say? The starting amount of money. Perfect. The starting amount of money. So we're going to stop here for today. We will finish part 2 or part C in our summary tomorrow, and you will get homework tomorrow.